All right, let's talk about cracking the coding interview. If you're prepping right now, you totally know the pressure. But what if I told you the secret isn't memorizing hundreds and hundreds of solutions? What if it's actually about mastering just a handful of core patterns? Well, today, we're going to show you exactly how to do that. Does this sound familiar? You're spending weeks, maybe even months, just grinding through problems, right? Trying to cram every single solution into your head, just hoping, that the right one shows up on interview day. It is exhausting, and let's be real, there is a much better way to do this. So here's the smarter way to think about it. Instead of an endless list of problems, what if you only had to really learn about 17 core patterns? That's it, just 17. You master these, and suddenly you have the toolkit to solve problems you've never even seen before. Now that's a game changer.
Okay, let's start building that arsenal. First up, we've got Section 1, the core toolkit. You can think of these as the absolute foundational patterns for the most common things you're going to face. We're talking arrays and lists.
So this first set, this is your efficiency toolbox. For example, if you see a problem that asks for the longest or shortest substring, your brain should just immediately light up and think, sliding window. It's kind of like moving a picture frame across your data to find the perfect shot. And the same logic applies to the others. A fixed range of numbers, like 1 to n, that's a huge clue for cyclic sort. And if they ask you to reverse a list without using extra memory, that's a classic job for in-place reversal. Now, this is super important. We've got two powerful pointer techniques that look similar but are for totally different things. On the left, you've got the classic two pointers pattern. This is your secret weapon for sorted arrays, and it can turn a really slow brute force solution into something lightning fast. Then on the right, we've got fast and slow pointers. You might have heard it called the tortoise and the hare approach. This is the absolute gold standard for one specific thing, detecting if a linked list has a loop in it. And this slide, it's a perfect illustration of the merge intervals pattern. This is what we call a classic greedy approach. And greedy just means you make the best possible choice you can at every single step. So think about it like meeting times. You sort them, and then you just go down the list, merging any that overlap. By focusing on that one simple local decision, you actually end up with the perfect global solution. It's really clever.
All right, so we've handled the straight line stuff, arrays and lists. Now it's time to get into the more complex structures. We're heading into the world of trees and graphs, and for that, we're going to need a whole new set of tools, the navigators. Okay, these two are the absolute bedrock of exploring a graph. You've got breadth first search, or BFS. The best way to think about this is like dropping a stone in a pond. It explores outwards in ripples, layer by layer. That's why it's perfect for finding the shortest path. Then you have depth first search, or DFS. This one's more like a maze runner. It dives deep, going all the way down one path until it hits a dead end, and then it backtracks. Two totally different strategies.
These next three are some serious power tools for your kit. So, if you ever see a problem about dependencies, think course prerequisites, for example, your brain should scream topological sort. It literally lays out the exact order you have to do things in. Then, for any questions about network connectivity or grouping things together, union find is almost always the fastest way to go. And finally, for generating every single possible combination or permutation, that's where the subsets pattern comes in. Okay, now this is just elegant. The subsets pattern boils down to a super simple recursive template. For every single element, you just make two choices. You either include it in your set or you don't. So you choose it and explore what that looks like. And then you unchoose it, you backtrack, and explore the other path. It's this beautiful, simple logic that unlocks a whole class of really complex problems.
All right, you've got the fundamentals. It's time to level up. We're getting into the pro-level plays now. These are the advanced techniques that can really separate a good interview performance from a great one. This is how you show you can handle the really tough stuff.
Most people see binary search and they just think, oh, that's for finding a number in a sorted array. And yeah, it is. But the pro move, the really big brain play, is to use it on the answer space itself. For really complex optimization problems, you can literally binary search for the best possible result. It's a complete shift in how you think about this tool, and it is so powerful. So why is this such a big deal? Because it gives you what's called O log n time complexity. And all that fancy term means is this. Even if your data doubles in size, the number of steps you need to find the answer only goes up by one. It's insanely efficient. That kind of performance is the absolute gold standard in this field. Look, just like a mechanic has a specialized wrench,
Sometimes you need a very specific tool for the job. You need to find the top K trending items from a massive stream of data. That's a job for a heap. You have to merge K different sorted lists into one big one. You'll want to use a K-way merge with a min heap. And, my personal favorite, you need to find the one unique number in an array where everything else is a duplicate. The bitwise XOR trick solves this, and it feels like actual magic.
Okay, dynamic programming. I know, it sounds super intimidating, but the core idea is actually incredibly simple. It's just this. Don't solve the same problem more than once. That's it. You break a big problem down into smaller, overlapping pieces. You solve each small piece and, here's the key part, you save the answer. So the next time you run into that exact same small problem, you don't recalculate it. You just look up the answer you already found. It's really that simple.
And finally, we have to talk about the true Swiss Army knife of data structures, the hash map. Seriously, this thing is used everywhere. Frequency counting, checking for anagrams, you name it. And here's a little pro tip for you. One of the most powerful combinations you can pull out in an interview is using a hash map together with the sliding window pattern. It's a killer combo.
So there you have it. That's the whole framework. We've got the core toolkit, the navigators, and the pro-level plays. You basically have the map now. So what's the final step to actually mastering all this? Well, you probably guessed it. It all comes down to practice.
So I want you to think of this as your mental map. From now on, when you see a new problem, you're going to ask yourself a few questions. First, is this about linear data like an array or a list? If yes, you're reaching for the core toolkit. Second, is this a tree or a graph problem? Okay, time to use the navigators. And finally, does this require some serious optimization or a specialized approach? That's when you bring out the pro-level plays. This framework right here, this is how you're going to approach any coding challenge from now on.
Look, just knowing these patterns, that's only the first step. The real skill, the thing that's actually going to land you the job, is being able to look at a brand new problem and instantly recognize which pattern is the right tool for the job. And there is only one way to get that skill: hands-on practice.
So, I'm going to leave you with this question. Which pattern are you going to master first? Don't just close this and move on. I want you to act. Pick just one pattern from what we talked about today, head to the link you see on your screen, and go solve a few problems with it. That is how you start your journey. That's how you really start cracking the coding